Okay, guys, so they're giving you that equation 2 sine x plus 30. They're asking for the period. Firstly, now guys, because there's no number in front of that bracket or in front of the x, the period is just a normal period, which is 360. Okay, the amplitude, remember amplitude is the number in front of sine cosine, unless it's negative, right? Remember we spoke yesterday that the amplitude can never be negative. So if it was like a -2, the amplitude would be 2. Okay, that actually happens in the next one. So the amplitude is just 2. The range, guys, now you can either visualize this graph. If you know that the amplitude is 2, right? Then that means that it's going to go up to 2 and down to -2. So that is your range, right? From -2 to +2. But what you also could have done, and I did mention this yesterday, you could have used the calculator and you could have just decided to put this graph into the calculator. Now, I think asked me yesterday what to put in as your start and end, because they didn't tell us that, right? If they don't want us to draw the graph, they're not going to tell you what your starting and your ending values are. So guys, if you do that, if you want to put the graph in the calculator just to see what points you have, maybe what asymptotes you have, just put it in for one period. Okay, so here the period is 360. So if you just put this in, let me do this quickly. If you just type 2 sine, what is it, x plus 30, right? Let's just go for one period. So I'm just going to go from 0 to 360, right? Because the period is 360 degrees. Because if you put it in for one period, you're going to see all the points that will be on that graph. Remember the points or the graph repeats itself every period. So what you have in one period is going to be exactly what happens in the next. Okay, so there, the step, we know that if the period is 360, the step is going to be 90. And there we are getting, oh, it didn't actually work for this one. I don't know why it didn't work for this one. Okay, so guys, the reason why it didn't actually work for this one, sorry, is because of this x plus 30 thing, okay? Because there's a 30 degree here. What does that mean? That means that the graph is moving 30 degrees to the left. So actually, the original starting point, right, which normally would have been, where does the sine graph normally start? Normally starts at the sine graph. If you just think, where do you normally draw it? If you go from 0 to 360, you normally draw it from the origin, hey? I'm supposed to know this, the basic graph. You're supposed to know that sine starts at 0, goes up to 1, down to -1, and back to 0. Okay, those are those basics. You have to know that. Okay, so this graph would normally start at 0, but now this one is moving 30 degrees to the, remember if it's an x plus 30, it's moving in the negative direction, right? We discussed that. Are we all okay with that? Just knowing that if it's x plus 30, it's moving 30 degrees to the left. So guys, the normal starting point that would have been 0, 0 is now actually going to move 30 degrees to the left. So it's going to be at -30 and 0. So actually, when we're putting in our start, we should actually start at -30. Yeah. Yeah, isn't that what I wrote there? Negative cos 2. Oh, yeah. Oh, sorry. Yes. Okay. Sorry. So that is wrong. Thank you. I'll fix that now. Yes. Yes. Okay, guys. Are we understanding this? But this is something new. We haven't actually done it before. All right. So please write this down on the slide. So if you have an x plus 30, that means that the normal, actually every single point, right, is going to move 30 degrees to the left. But if we want to use the calculator to figure out what the range is going to be, yeah, that's what we're trying to do here. We want to get all the points of interest, right? All the 90-degree points, the points that have 90 degrees. Okay? We want to get all those points on the calculator so that we can see what our lowest y value is going to be and what our highest y value is going to be. Right, so sorry that I didn't warn you on this. I just did this kind of by visualizing. Okay, but it's good that we're having this discussion. So if it was just 2 sine x, you could have just gone from 0 to 360. Okay, because that graph is not going to shift to the side. But if it's an x plus 30, and you want to put the start value in here, did you see what we got when I put in 0 as my starting value? I got like negative 1,73. Okay, that's not right. So you would have to then put in almost like your new starting point. Instead of 0, you would have to put in negative 50. Okay, let's see if that works. 350, or you can go to 351. Yeah, but 350 would then be 1 period. Okay, so let's do 2 sine x plus 30 degrees again. All right, now for my start, I'm putting in negative 50. Okay, and for my end now, we can keep it as 360 or we can do 350 so that it's just 1 period. Step is 90 still. There we go. All right, now we see that we're getting points that actually look like points on a cos graph. What is this? A sine graph. All right, so there we see, there we have that starting point, right, that I wrote down there. The point negative 50 and 0. Then 90 degrees further on. So at 60, we have the next point. Why 90 degrees further on? What is 90 degrees of this graph? The step, okay? So if you're starting at negative 30, your next point is going to be 90 degrees further on to 60. Then another 90 degrees further on. Right, do we see that we have positive 2 there? If we move down, we have negative 2. Okay, so do you guys see what I'm saying? Right? If you have your table, you can actually see what your lowest y value is and your highest y value in your table. Okay, to get your range. All right, so that was a long conversation on that. Let me just fix this. Let me just write here. This is the new starting point. Okay, then for the y-intercept, I'm going to fix this next one. I did make a mistake in the next one, but for the y-intercept here, remember we spoke about this also yesterday. For the y-intercept, you always make x equal to 0. So you're going to take your equation, 2 sine 0 plus 15, and this you type into the calculator manually and you'll get an answer. If you're asking for the y-intercept, guys, they want it for ordinates. So you can't just say y equals 1. Unfortunately, you have to then take your x value, which is always going to be 0 for the y-intercept, and the y value that you get with it. So you have to write those for ordinates. All right, number, I'll try the first one, guys. Sorry about this x plus 30 thing now, but I think it's good that we did have this conversation. All right. For the next one, negative cos 2x, like I said, I'm going to fix this y-intercept now. I did make a mistake there. Okay, but for the period, guys, now we have a k value of 2. All right, so remember your period is going to be the normal period of a cos graph, which is 360 divided by 2. Whatever your k value is. So that is where the 180 is coming from. The amplitude, guys, what number is times of cos 2x is actually a negative one, right? But remember we discussed this yesterday, your amplitude can never be negative. So the amplitude is just a positive value that's there in fact. The negative actually reflects it in the exact. Okay, so if you're asking for amplitude, that's always positive. For your range, again, you could have just done the table function. It actually would have worked this time if you went from 0 to 360, not shifting. Okay, it's not going to the side. So you would see that your smallest y value is negative 1, the greatest y value is 1, so that is the range. Okay, let me quickly fix this y-intercept here that I just incorrectly. So it was negative cos 2x, right? So y equals negative cos 2 times 0. So that is just 1, hey? Negative 1. Negative 1, no. There you go. Again, for your y-intercept, you make x 0, so you put that into the equation and you get your answer on the calculator. Okay, next one, tan 2x. Now again, guys, there's a 2 in front of the x, so that's going to influence the period. The normal period of a tan graph is 180. So with this one, you're going to get 180 over 2, which is just 90 degrees. That's where that answer comes from. But as you remember, if they're asking for the amplitude of a tan graph, there is no such thing. Tan graph does not have an amplitude because it doesn't have a maximum point or minimum point. Right? So for tan, the amplitude is none. The range, I wrote y an element of real, but you also could have written y as an element of negative infinity to positive infinity. Guys, that will always be the range of the triangle. Okay, you can actually memorize that because you have an arrow at the top and an arrow at the bottom. Okay, so the y-intercept, do we agree with that one? Make x equal to 0. So tan 2 times 0, that is the 0. So you need to write 0, 0. Now, I don't think I'll take off a mark if we don't have that degree symbol there, but let's try and remember it, okay, just in case. Okay, so 1.4. Sine 2x minus 20 minus 1. Now for this one again, if you wanted to type it in, you would have had to change what you typed into the calculator. Did anyone try that? Did anyone try and use the calculator to get the range there? Yeah, this was also a tricky one because of the minus 1. Now guys, here, remember I told you that the k value is actually the number that's supposed to be in front of the bracket, right? So we are actually supposed to rewrite this equation. So this is actually k of x equal to sine. You're supposed to take that 2 out of the bracket. The 2 is inside the bracket, so that hasn't come up yet. So just write this down, please. And that's then supposed to be x minus 10 minus 1. So if you have a bracket, right, if you have a horizontal shift, a shift to the left or the right, and the number in front of the k value is actually in front of the x, so it's inside the bracket. It's supposed to be outside the bracket. Okay, so you do have to take that out as a common factor there. So please do that. Okay, so now if you wanted to use the table function, what shift is happening here, right? Is it an x minus thing instead of right? Remember, there's an x minus, it's shifting in the positive direction. So this is shifting 10 degrees to the right. So again, we need to think, what is the normal starting point of a sine graph? 0, 0, right? Look at this. Yes, but when we take the 2 off, it becomes a 10. Okay, so that's the thing that we haven't looked at before. So that is important, guys. You actually are taking the 2 off as if it's a common factor in this bracket. Okay, that's only if the 2 is in front, inside the bracket. If it was outside the bracket, then it would be 2. Okay, so this is 10 degrees to the right. So guys, again, what is the normal starting point of the sine graph? The origin, 0, 0. Okay, this one actually is not going to be 0, 0. It doesn't really matter what the y value is. But let's quickly think, what does this minus 1 do to the graph? To the minus 1 at the end. It shifts it down, hey, by 1 unit. So this graph would normally actually start at 0, negative 1. Okay, but that's not really important. We can just say 0, 0 for this because we are just talking about that shift. All right, we're actually interested in the x value because that's what we're putting into the calculator as our starting point. Okay, so that's all you really need to worry about at this point is the 0. So that is now moving 10 degrees to the right. So what is the new starting value going to be? New starting point is going to be at 10, not at 0. Okay. So this one is going to be at 10 degrees. But then actually because of this minus 1, it's actually going to start at 10 degrees and negative 1. But we don't have to type that minus 1 into the calculator. Okay, so I want you to straight about that y value. And what I'm actually trying to see here is if I want to type it into the calculator, what must I put in as my start? Okay, this new starting point of the graph, which is going to be at 10 degrees. So let's see what happens when we type that in. Now guys, you can decide to type it in like this with the 2 inside the bracket or like this with the 2 outside the bracket. It's up to you, it means the same thing. So sine of, let's just do it like this, 2x minus 20. Then you have to close your bracket, guys, and then put your minus 1. Okay, if you put your minus 1 inside the bracket, it's not going to give you the right stuff. Okay, gx, we're not doing another drop. So now my starting value is going to be at 10. Okay, let's quickly see what is the period of this graph. If there's a 2 in front, what's the period of a normal sine graph? 360, so now I must divide that by 2. So there's a lot going on with this graph, okay? So this one, the new period is going to be 360 over 2. So the period is going to be 180. So guys, if I'm going from 10 and I add the period to it, what's 10 plus 180? 10 plus 180 is 190. Okay, so I actually only have to go to 190. That's one full period. Now we need to talk about step. So that's the next thing that we must hold in. But if the period is 180, the step is going to be 180 divided by 4. Okay, I'll put that just here at the bottom. So the step for this graph is actually 45 degrees. Okay, that we also need to know if we're going to type it into the calculator. So 45. And there we now are getting all our points. All right, so we're getting that starting point. You see 10 negative 1, that's what we said. Hey. Then the next point is 45 degrees further on, because that's the step. So at 55 and 0, we have our next point. Then another 45 degrees further on again, because that's the step. We have negative 1. All right, so there we can just see, okay, here it looks like the smallest value is negative 1, but oh, here we have negative 2 actually, okay? All right, so what is our smallest y value here? Negative 2, and the biggest one is 0. Okay, so that is your range. All right, y-intercept. Again, you make x equal to 0, so in your equation, you just type that into the calculator. Did we all get negative 1.34? Yeah. Right, so that is the y-intercept thing. On the equation so far. This one was quite complicated. This graph. All right, let's look at 5 and 6 there on the next page. So 1.5 there. This one wasn't too bad. Okay. Here now the k value though is a half. Now we have worked with that once, but we also had tan half x. So remember that the period of a tan graph usually is 180. And now divide that by a half. All right, that's how you get 360 for that one. Again, guys, the amplitude, there is no amplitude of a tan graph. Okay, it has an a value. The a value is 3, right? But with the tan graph, the a value is not the same as the amplitude. Okay, the range, again, like I said, for tan graph, it's always y element of real, or you can say y is an element of negative infinity to positive infinity. Up to you, both will be marked correct. And then for the the y-intercept, again, we make x equal to 0 and move across. So you're going to type in 3 tan or half times 0, and that is again 0. All right, so this graph is just starts at 0, 0. That's y. That's the origin. Okay, for Q, we again, if we want to use the calculator, we're going to have to type in a different starting value. It's not so complicated, this one, because there's no number in front of you. Okay, so the period is the normal period of a cos graph, right? There's no number in front of the x or in front of the bracket, so it's just 360. And this period doesn't change. The amplitude is the number in front of cos, so the amplitude is a half. Right? That actually means that you're starting at 0, well, if the middle value is at 0, you're going to go up to a half and down to negative a half. Okay, and if you know that, then it's actually easy to just think that your range is going to be from negative a half to positive a half. Okay, you don't have to use the calculator always for the range. Sometimes it's just easier to understand what does the amplitude actually mean. So if your amplitude is a half, that means that the graph is going to go up to a half and down to negative a half. So if you know that, you can just say, okay, then my range is obviously going to be from negative a half to positive a half. or you can type it into the calculator. If you do that though, what is happening here? What shift is happening? It's minus 20. Where does the card graph normally start? Or what is the y-intercept normally of the card graph? What's the starting point normally? At 0, right? But then at the highest point. Okay, so it normally starts at 0. I'm going to write here starts at 0 degrees, but now because of this minus 20, this is shifting 20 degrees to the right. So this one is going to start at 20 degrees. All right, so normally it starts at 0, but now it starts at 20. So if you want to use the calculator, your starting value is going to be 20 and your end is going to be 380. Okay, from 20, 360 degrees. So that's going to be start. I'm not going to do it now on the calculator, but I'm just going to write here ends at 380. Okay, if you wanted to use the calculator, those would be the start and end values that you So it depends on what they've given you. If they've given you the equation, you can just write that number down. Because the amplitude will always just be the number in front of sine cos. But if they've given you the graph, for example, and not the equation, then you'll have to use the formula. So then you'll take the biggest one minus the smallest one divided. Okay. All right, guys, any other questions on this exercise? Okay, then for that other one that I changed yesterday, exercise 6, you had to do these two graphs. So I hope that the message got to everyone that we changed the equation of the one graph. It was originally, I think, x minus 30, we changed it to x minus 90, and I also changed the domain that was given. All right, so x of x is the blue graph, yes. All right, sine x minus 90 minus a half. Now guys, this minus a half, that shifts the normal sine graph now, half a unit down. Okay. But this one is also shifting 90 degrees to the right. So let's quickly see if we can identify the new starting point just by looking at my graph, right? Normally a sine graph starts at 0, 0. Yes? Now shifting 90 degrees to the right. So that will be at 90 and 0. But it's also shifting half a unit down. So 90 and negative a half. Do we have that point on the graph here? There we go. All right, so that point actually is like the original starting point of the sine graph that has shifted 90 degrees to the right and half a unit down. Okay, so just circle that point there so that we know that that is like the new starting point. And then from there, I will follow the shape of the normal sine graph, right? What is the amplitude of the sine graph? What number is in front here? 1. So from our starting point, it's supposed to go 1 unit up, right? Here we go. Going from negative a half to positive a half. You see? 1 unit up. And the step here is also 90 degrees. So that's why it's after 90 degrees it goes 1 unit up. All right, so now we know the shape of the sine graph. It starts at the middle, the starting point, which is this one, goes 1 unit up, then it goes 1 unit down again, you see there, and then another 1 unit down. Okay, so yeah, I almost want to say if you know the shape of the sine graph, you actually don't need to use the calculator. All right, it might save you time if it's an easy-ish one. This one is a bit complicated because there are 2 shifts going on. But maybe for 2 cos x, maybe you don't need to use the calculator for that one. All right, we're going to talk about that one now. I'm just thinking in terms of like in a case for exam, what can we maybe cut some time down? Okay, are there any questions on that blue one? Now guys, for the, I don't know what color is this, peach, pink one, 2 cos x. Let's just quickly think. We know what the normal cos graph looks like, right? Cos. Starts at 1, down to 0, down to negative 1, back up to 0, and then back up to 1. But now because this is a 2, the amplitude is 2. That means that it started instead of starting at 1, it will start at 2. Right? Do we see that? So the starting point, this graph is not shifting at all. It's not shifting to the side. It's not shifting up or down. right? There's no degree values here in the bracket, and there's also no plus or minus thing after the whole thing. So the only thing that's happening to this graph is instead of going from 1 to -1, it's going from 2 to -2, right? Because of this amplitude. So maybe if you know that, maybe it can save you some time, right? And you don't have to type anything into the calculator. So your starting point for class graph is always at the maximum point, the maximum value at 2 in this case, because of that amplitude. Then you're going to go down to 0 after 90 degrees, right? Because the step is 90. Then you're going to go down to -2. Back up to 0, back up to 2. Okay, and when you're going backwards, guys, you're going backwards from 0, you need to make the shape backwards as well. So from 2 there, you're going to go down and then all the way down again. Okay, that's just a suggestion. You can obviously still use the calculator if that's something comfortable. There's nothing wrong with that. Then they just asked a few kind of like basic questions here. They asked for the period of f. Now, if we look at f, there's no number in front of the bracket or in front of x. That's the normal period, right? 260. They asked for the amplitude of g. Now, the amplitude, just the number in front of target. So that's 2. Right? And then they asked for the range of f, right? So f is the blue graph. So for the range, you've actually drawn the graph. You can just look at what your smallest y value is. So it's -1.5, right? Or -3/2, which is what I wrote there. -3/2, and the highest y value is 1/2. Okay, so that is the range of this graph. You just look at your actual graph and you go from your smallest y point to your biggest y point. Okay, I'm just going to leave the graph up to a little bit so that you guys, everyone needs to have this. And I really want to copy this down. Make sure that you copy down the graphs here. And guys, you have to label the graphs as well. Remember, we've spoken about that. If you have more than one graph on the same set of axes, the blue one, you can just write an X somewhere next to it. It can either be on that side, it can be down here, as long as it's somewhere next to the X graph. All right, next to the blue one. And then for G, I labeled it up there because there was a nice gap there, but you could have put the G there or over there, all right, anywhere where it won't kind of overlap with the other graph, if that makes sense. There needs to be a nice gap just next to the one graph, and then you label it as G there. Okay, I'm just going to do a final absentee check here quickly. Guys, who does art in this one? Three of you. Okay. Are there any questions on this one? Can we move on? Okay, the new heading is finding the equation of a true graph. You can start writing that so long, finding the equation of a true graph. Okay, guys, that's the first thing. We're just going to actually draw the three basic graphs now. That is important, guys. We're going to give you a graph. They might not tell you this is a sine graph or a graph or a tan graph. Alright, you need to be able to identify which type of graph it is. But then you also need to know what the basic graph looks like so that if it's different, you can tell how it's different. Okay, so these are now the three graphs that you have to memorize. You need to be able to draw them quickly and you need to be able to identify it. All right, so the first one that I'm going to draw is y equals sine x. And we're just going to draw it from 0 to 360. And guys, for the normal sine graph, right? The period is 360, so the step is 90. Okay, that's also another thing that it helps if you just kind of know that. You don't still have to think about that, like what is the period again? How do I find the step again? Okay, it's good if you know that kind of with by heart. So the period of just y equals sine x is going to be 360, so the step is going to be 90. So when I'm now drawing this basic one, I'm going to start from 0, I'm going to go to 360 because that's the period, and I have a notch at every 90 degrees. Okay, and now, guys, we don't want to use the table for this. And that's going to waste time. Just remember that a sine graph, and we have discussed it already today. The sine graph starts at 0, 0 at the origin. Then it goes up to 1, back to 0, down to -1, and back to 0. That is the shape of the basic sine graph. This determine and then we just want to write in our coordinates or the points that are not on the axes. So we have the point 90 and 1, and we have the point 270 and -1. So that's the basic sine graph, right? You need to know that shape. All right, at least you need to know that it starts at 0, 0, the origin. So that if you have a point at 30 and 0, you can see, okay, that's a sine graph that has been moved 30 degrees to the right. That kind of thing. Okay, that's what we need to be able to identify. The next one that we're going to do is y equals cos x. For this one, the period is also 360. It's just the basic one, guys. We're not changing anything. Period is also 360, so the step is also 90 degrees. Again, we're going to draw the same set of axes, all right? Again, from 0 to 360. So guys, the cos graph doesn't start at the origin, it doesn't start at the middle value. If you look at the sine graph, right? It starts at the middle value. Okay? The cos graph starts at the biggest value, the maximum value. Right? So the cos graph is going to start at 0, 1. And because that's the biggest value, from there it's going to go down. Okay, so from there it's going to go down to 0, then to -1, then back to 0, and then back to 1. The cos graph has that kind of shape like a bowl, all right? I obviously went to another class high school, and my teacher said it looks like a force party. Maybe that helps, all right? Force party, that's what we call it. So there we go. We just do that. We start at the biggest value, and then we go down to -1. Now we can just connect those points. Okay. Okay, again, guys, let's just label the points that are not on the axes. So we're labeling 180, -1, and 360, and 1. So guys, before we go on to the tan graph, I just want us to make some notes about each of these graphs on the side of them, if you have things next to them. Otherwise, you can just make like a star and just write y equals sine x and write some stuff about it next to it or underneath. So for the sine graph, because now guys, we need to know the basic graph, and then we need to be able to identify which changes have been made to the graph. Because to be honest, they're not going to give you y equals sine x and ask you to find the equation. Right, that's too basic. They will change something about that graph, and you need to be able to identify what changes. Okay, so the first thing that's usually the easiest thing to see is when the graph has shifted up or down. Okay, so that's something that you can keep an eye out for. So what I want you to do is I want you to, when you're getting a graph and when you see, okay, this is a sine graph, I want you to identify what the middle value of the graph is. So we're all going to do examples, but that is the easiest thing to see normally. All right, what the middle value of the graph is. So you're going to look at the shape of the graph, right? And guys, remember, it might not always start at 0, 0. It might start over there, it might start somewhere in the middle. Okay, I want you to identify, you have a point that's going up and it's going down. All right, you have a value in the middle. I want you to identify that middle value. All right, so that is the first thing that you're going to look out for. identify middle value. And guys, that middle value, what that is, will tell you what the Q is. Okay, we're going to do some examples. But the middle value is going to help you to identify Q. Maybe I should just write the standard form as well quickly. We're thinking of y equals a sine k bracket x minus p plus q. Right, that is the standard form. So those are the various changes that they can make. Right, so we've just drawn sine x. We need to think, how can we identify what the q value is? You're going to look for your middle value. Okay, you'll see when we do example how that works exactly. The other thing that you're going to have to do is you're going to determine the amplitude, calculate the amplitude. All right, we do have a formula for that. I'll write it again. So calculate amplitude. Remember that that was max minus min, so maximum value minus minimum value over 2. And guys, what is the amplitude? That is your A value. Right, but now it might not always be the exact A value because you can't tell what the sign is just by that. Okay, so this is going to give you the A value, but along with the direction of the graph. So I'm going to say calculate the amplitude, which is that, plus look at direction to identify A. Okay, now what that means. Provided your A value is positive, right? If A is greater than 0. Then your sine graph is going to have this shape. It's going to start at the middle, it's going to go up and then back to the middle. Right? That is if your A value is positive. If your A value is negative, the direction is going to be the other way around. So the normal sine graph, right? From its starting point, it goes up. If from the starting point it's going down, then you know that your A value is negative. Okay, so that's what I mean by direction. If instead of going up first, it's going down first, then your direction or then your A value is negative. So it's from the middle point, you're going down and then back up like that, then your A value is negative. I'm sure this will be a bit clearer once we actually are looking at examples. So don't stress if you're feeling a bit lost or something. And then guys, when your graph has shifted to the left or the right, that is normally quite obvious. Okay, so I'm not going to write the specific thing down for that. You'll just see that on the graph. Okay, it's quite clear. It's quite easy to see that. You just need to look for the starting point, but you'll look at it after that. Okay, so that is for sine. Let's quickly do a similar thing for the cos graph. It is very much the same. It's just the direction that's different. Okay, so when we're talking about the cos graph, the standard form, the standard form is y equals a cos k bracket x minus p plus q. Now for this one, instead of identifying the middle value, right, I'm just going to go back over to the graph quickly. For the sine graph, it starts at the middle value, right? Where the cos graph starts at the maximum value. So normally to see if the graph has shifted up or down, you need to look for that maximum value. Okay, and see where that is. That might not be the first thing that you look at for this cos graph, but I'm just going to write it down. You'll see when we do examples, sometimes it's quite easy to see what happened to the graph. Okay, you don't need that a step-by-step thing, but it is helpful to know what to look out for. So for the cos graph, you are going to identify the maximum value instead of the middle value. Yeah, the middle value won't necessarily tell you whether it's shifted up or down. So identify a maximum value, and that will allow you to identify Q. And then you're going to do the same thing. You are again going to calculate the amplitude, and you're going to look at the direction. I'm not going to write the amplitude formula again. We do have it there. All right, but you're going to calculate the amplitude plus look at direction to identify A. But now the direction is a little bit different for the cos graph because it looks different from the sine graph. So for the cos graph, if your A value is positive, it's going to start at the maximum value, it's going to go down and then back up. Okay, it's going to look like the force blocking if A is positive. But if A is negative, it's going to start at the minimum value and it's going to go up. So it's going to be like an upside down ball, all right? So if A is negative, it's going to start here, go up like that, and then go back down. All right, so that is the direction that you need to look out for with the cos graph. Just want to highlight these on the screens before. Okay, now maybe I shouldn't do Okay, guys, I'm just going to look at, yeah, we're not going to do tan yet. Let's rather just do sine and cos first in terms of practicing it. It is also, yeah, we have about 10 minutes left. So we're quickly going to look at exercise 8 in the textbook. Which is on page 150. Now I want us to look at number 1. I'm just going to take a picture of this graph. Sorry, it's one second. You guys can go to the page in the book so long as you have your textbooks here. I'm just going to put it on this picture as well. Okay, so that is what they've given us. Sorry, that's a bit dark. Okay, but they've given us, do we see that there are 3 graphs? Alright, so it looks very complicated, but let's just focus on one graph at a time and see what's going on here. So guys, in the textbook they have like 1.1, 1.2, 1.3. What I actually just want us to do is define the equations of these graphs. Alright, so if you're looking in the textbook, they have 8 questions on this. All I want us to focus on is what is the equation of, let's see what the names of these graphs are. There's an F. Alright, so the red one is F. So what is the equation of F? What is the equation of this blue one over here is G. And then the other one, the green one, I don't know if you guys can tell that that's green, but that one is H. Okay, that's all I wanted to focus on. We're not going to get distracted by all the other questions that they've asked there, so don't worry about that now. All right. So let's look at F first. I'm going to do F with you guys, and then you're going to have to do G and H on your own for homework. So if we're looking at F, now guys, the thing with sine and cos graphs is often a graph can either be a sine graph or actually a cos graph as well. And you can almost like decide, does it look like a sine graph to you? Does it look like a cos graph to you? So if we're looking at F, right, what we're going to try and do is we're going to see where is the starting point. Because guys, can you see that this F graph, there's nothing here at the origin. All right, so there's no, it looks like this graph has shifted to the side. You see that? That's what I meant when I say that it's quite easy to tell when a graph has shifted to the left or to the right. I think it's quite easy to see here that this graph has a point at 30. That's not normal, right? We don't normally have a point of or point at 30 on a sine graph. Okay, so let's see, guys. I'm going to say that this is a sine graph. So what I'm actually going to do is I'm going to say y is a sine k bracket x minus p plus q. Okay, write down the standard form. Then we're going to go through all of them and see if we can calculate them. All right, and at the end, we'll write them together in the equation. Okay, A, the amplitude. How do we find that amplitude? We go from the maximum value minus the minimum value and we divide by 2. Okay, now guys, before we do that, let's just quickly see. I think that that point is a new starting point, right? It looks like the graph has shifted there. So if you, I mean, you obviously don't have this graph in your books now, it's in your textbook, but I would circle that graph. And it seems to exam, you are going to get the graphs on your question sheet, right? So you can circle that. So to me, it looks like the new starting point is at 0. At 30, sorry. I'm going to write that down. New starting point at 30 degrees. Positive 30. Yes. Yeah, it's usually because some people would say that. Some people would say that that looks like the starting point. But this is not the closest point to 0. So yes, we generally do choose the point that's closest to the origin. Okay. All right, guys, if we have a new starting point at 0, what does that mean for my bracket? What is my bracket going to have? Sorry, I keep saying 0. New starting point at 30, at positive 30. What does that mean? What is my bracket going to be? X minus 30. Okay, there we already have the bracket. So we can fill that in so long. So y is going to be a sine k bracket x minus 30 degrees plus q. Remember, if it's moved in a positive direction, then we put a minus in the bracket. Okay, so one thing is already sorted out. And the reason why I say that is because if we're looking at our starting point, we need to now also look at the direction. The sine graph normally goes up first, right? From our starting point here, what's happening? It's going down. So that means that my A value is going to be negative. Okay, so when we're looking for A, I'm just going to write it here. The direction from starting point is down. Okay, we need to know that the normal, the direction of the normal sine graph is A is positive, is that it goes up. from the starting point. Now it's going down from the starting point. So that means that our A value is going to have to be negative. But now how do we actually get the value? All right, how are we going to know? Is it 1, is it 2, is it 3, whatever? By using that formula. Okay, so the value is going to be, I'm going to write here A is equal to, and let's put a minus there because we know that the answer has to be negative. All right, what is the highest value that I have on the green graph? It is 1. And the lowest one is negative 1. All right, so we can say 1 minus negative 1 divided by 2. Now this you can type into the calculator or you can just work it out in your head. It's going to be 1 plus 1, which is 2. Divided by 2 is just 1. All right, so my A value is actually going to be negative 1. So guys, you see, you use the formula, but you also have to look at the direction. So you can't just do the formula. You have to see what is the direction. So the A value is negative 1. So we know from that now that Y is negative sine K x minus 30 plus Q. Now guys, to find your Q value, I know we're almost done. Does it look to you guys like this graph has moved up or down? If we're going from 1 and then to 0 and then to negative 1, has this graph moved up or down? No, okay? The middle value is directly in the middle between 1 and negative 1. So Q is actually 0. You can just write that there. Q is 0 in brackets has not moved up or down. And now guys, quickly, to get K, we have to check what the period is. All right, so the period, remember, is one full curve. So let's see, if we're starting here at negative 360, how far until I get that, say, until that whole shape is completed? Do you see that at 0? Do you see that that is like a full sine curve? All right, so from, it looks like that's at a half, from a half, down, back to a half. So the period is 360. Okay, you can tell that by looking at the graph. So if my period is 360, what is K? What do you guys think? Did I divide by anything? What's the period of a normal sine graph? 360. So K is 1. Okay, K is 1. All right, you guys don't actually have to do the other two. I think they're a bit complicated. We'll do them together on Tuesday. So you have a 3 meeting. In terms of maths. Thank you guys. I hope you have a nice long weekend. I'll see you next week.